So next solution that we have is the campus network virtualization solution, which is the solution we use, the VXLAN. Okay, VXLAN technology. So again, in our cloud campus network architecture for VXLAN scenario, again, we have the network management layer, the management layer, okay, and then we have the application layer. So in application layer, again, we have the third-party apps, okay, which we will use the API to collect the data, okay, collect the data, and then we have our iMaster, and then iMaster will use netconf, okay, to manage and to configure the network, and our campus insight will use telemetry to collect information, okay, collect information from the network layer. So, okay, as you can see here, compared to the cloud managed network, right? Now we have we have three layers, okay? Three layers inside the network layer, okay? So inside the network layer, we can actually separate it into underlay network, fabric, and overlay network, okay? So what is mean by underlay network? Actually, underlay network is just the physical network, okay? For example, the core switch, aggregation, access switch, okay? So in the underlay network, usually we will have the interconnection IP, okay? And then we have the interconnection VLAN. And in between, we have the protocol, for example, OSPF, okay? So all this network layer, we call it as underlay network layer, okay? So above this overlay above this OSPF network or underlay network, okay, we will use virtualization technology, which is the VXLAN plus BGP EVPN. Okay, so by using these two technology, okay, we can form, okay, another layer. We call it as fabric layer. Okay, fabric. This fabric layer is above our underlay network, and from this fabric layer, okay, we will separate it into different layer. Okay, we can separate it into different virtual network. Okay, and each virtual network is isolated with each other, and all this virtual network we also call it as overlay network. Okay, so at here we can create a different virtual network for different services, such as maybe this one's for IP phone, this one for IPTV, and maybe this one for camera. So in this case, we can achieve different services inside one single network using the VXLAN solution. Okay. So next, so we'll go through the technology, the VXLAN. So basically, what is VXLAN? VXLAN is basically it's just a VPN technology we use to construct a virtual networks on a layer 3 network. Okay, what does it mean by constructing virtual network on a layer 3 network? Okay, for example, we have a network, we have our switches, okay, connect to each other, and then we use OSPF at layer 3 protocol. Okay, so above this, okay, this network we also call it as underlay network. So above this network, we will use the VXLAN, okay, VXLAN to form a layer 2, to create a layer 2 network using tunnel technology. Okay, so basically this is what it means by constructing a virtual network on layer 3 network. Basically, we will construct a virtual network above this layer 3 network. Okay, so okay, as you can see from here, below the gray color cloud, this is the traditional layer 3 network, or we can call it as underlay network. Okay, and in the underlay network, we will use the OSPF, ISS, or BGP. But in our solution, we will always use OSPF, okay, for the underlay. So after we have the underlay. Sorry? Are you asking any question? Okay, let's continue. So basically, okay, above the underlay network, in each switch we will configure something called VTEP, VXLAN tunnel endpoint. So this VTEP will be function to create tunnel, okay, to create tunnel between all devices, okay. And also this VTEP will helps to encapsulate and decapsulate the VXLAN packets. Okay, for example, we have PC1 and PC2. Okay, when the PC1 want to communicate with PC2, first it will send out a data packet, okay, a data packet to switch, for example, switch 1, switch 2. Okay, it will send a data packet to switch 1, and this data packets will be encapsulated, okay, encapsulate using VXLAN header. Okay, so encapsulate based on this VXLAN header, and then it will forward these packets to switch 2, and once this packet reach the switch 2, okay, it will remove the VXLAN header and send it to the PC2. Okay, so basically at here are some of the benefit of VXLAN compared to VLAN. Okay, so basically before I talk about this one, okay, in VXLAN we have something called VNI. Okay, VNI. Actually, VNI is similar to VLAN. Okay, you remember that in VLAN, okay, we can have, for example, VLAN 1, VLAN 2, and then in each VLAN is actually isolated with each other unless you go through layer 3 IP. Okay, and this case also apply the same with VNI. Okay, in VXLAN we can have maybe VNI 1, and then we have another one, VNI 2. So in between the VNI, they can directly communicate with each other. The device can communicate with each other directly. But if each VNI want to connect to each other, they need to go through layer 3. Okay, so these are some of the common terms inside the VXLAN. So by comparing the VLAN and VXLAN, okay, in VLAN it's just a layer 2 virtual network, and VXLAN actually we have the layer 2 network above of layer 3 virtual network. Okay, and in VLAN, as you know, we only can support up to 4096 VLAN. So in this case, we only able to support 4096 tenant. However, in VXLAN, we can support up to 16 million tenant. Okay, this is due to this packet header. Okay, at here, you can see we have the VXLAN header, and inside the VXLAN header, we have the VNI. Okay, you can see that in this VNI, we have 24 bits. Okay, if you know how to calculate by 24 bits, it means that we can support up to 16 million tenants. So this is one of the major benefit of VXLAN. Okay, so we can support more than 4096 tenants. And beside this, okay, we have additional reserve bits, 24 bits, okay, in VXLAN to identify user group. Okay, so in traditional VLAN, right, when we have a lot of users, right, we are not able to separate them into, for example, different user group. For example, security group, maybe we have another group of operating and maintenance group. Okay, in traditional VLAN, we are not able to separate them into different groups. However, by using VXLAN, now we are able to identify the user based on user group. Okay, so after talking about VXLAN, actually in VXLAN, right, we have some issue that we will face inside the VXLAN. The main issue in VXLAN is it doesn't have control plane. Okay, so without the control plane, all the host routes are advertised through static configuration, and all the data plane traffic will be flowed throughout the network. Okay, what does this mean? Okay, first, okay, for example, now we have a lot of switches which need to build VTP, VXLAN tunnel to each other. So in this case, okay, we need to configure the VXLAN peer. Okay, VXLAN peer. So imagine that if now we have 100 switches, okay, 100 switches that you need to configure at the same time. So this switch, you need to create 99 peers. okay, for VXLAN. And you will know that the configuration workload is very heavy. So this actually causes some issue. So this is the first issue that we'll face in VXLAN. The configuration workload is very heavy. Okay. And another issue that we will face inside VXLAN is data traffic flooding. It's used to synchronize host information. So for example, when user A want to access user B, okay, user A want to access user B, okay, the VTP A, when he want to find, okay, where is the user, he will need to find he will need to communicate to all the switch to know where is the user. So before he know, the VTP A will send the traffic to all the switches, okay, all the switches, just to find the user B. So after finding the user B, then only you can forward the traffic to user B. However, you imagine that if we have a lot of user, okay, we have a lot of user connecting to different switch, and then they want to find the user at the same time. So all the switch will be sending traffic around the network, okay? So it will cause traffic flooding throughout the network, okay? So this is another issue that we will face if we just using the VXLAN without a control plane. So again, I repeat, there are two problems that we will face if we use the VXLAN without the control plane. The first problem is configuration workload will be very heavy. Another issue is large number of traffic will be flowed throughout the network. Okay, so in order to solve this issue, in our cloud campus, we introduce something called BGP EVPN. Okay, so we use the BGP EVPN routes to help to exchange the VTP, okay, information, and then after exchange the information, all the switch will automatically discover the VTP and it will automatically form the tunnel in between all the switches. And beside this, the BGP EVPN routes will help to advertise the host information to each other. So in this case, okay, we will no longer need to configure the peer one by one. Okay, the BGP EVPN routes will help you to solve this tunnel issue, the first issue. And then another thing is BGP EVPN routes will help you to advertise the user information to the switch. So now when user A, for example, user A want to communicate with user B, okay, user A want to communicate with user B, okay, our switch will already know where is the user B and it will directly send this traffic, okay. So we will no longer need to float, okay, we no longer need to float all the traffic throughout the network. Okay, so what kind of routes that we use to solve this issue is basically in BGP EVPN we have these three routes: the type 2 routes, type 3 routes, and type 5 routes. The type 2 routes, we also call it as MAC IP routes. Basically, this MAC IP routes is used to advertise the host MAC address, ARP, and IP routes throughout the networks. Okay, and for type 3 routes, we have the inclusive multicast routes. Okay, in these routes, we will transmit the layer 2 VNI information and VTP IP address. So for example, okay, this one of the router, or one of the switch, when it will advertise the type 3 routes, okay, type 3 routes to their neighbor, okay, and this type 3 routes will have the VNI information and also the VTP IP address. So once the device receives this information, it will automatically create the tunnel in between. So now you don't need to manually configure, everything will be done automatically using the BGP EVPN routes. Okay, and the last type of route that we have here is the IP prefix routes. Okay, basically the IP prefix routes is used to advertise the IP host and IP network segment to external network. So for example, maybe we have one switch connecting to another network. Okay, network B. Maybe this is network A, network B. So when the device in network A want to communicate with device in network B, okay, it will use these type 5 routes, okay, in order to communicate with external network. Okay, so these are the types of routes that we have: type 2, type 3, and type 5. Okay. So next, these are the network architecture that we have in CloudCampus. So basically, okay, in CloudCampus, usually in CloudCampus, we will have the egress gateway, we have the firewall node, the border gateway, transmission node, edge, and access node. Okay, the main things that you need to focus is here, the VXLAN domain. Okay, inside a VXLAN network or VXLAN domain, we will have the border, and then we will have the edge. Okay, and between the border and edge, they will form the VXLAN tunnel. Okay, so let me explain one by one. Okay, what is the function for each devices? For egress gateway or external gateway, actually the external gateway is just allow the campus network to access the maybe internet or maybe WAN network, external network. Okay, and for the firewall node, it's just for L4 to L7 security policy. Okay, and it can be deployed by pass mode or campus. It can be deployed as egress gateway also lah. Okay, basically the firewall node is just for security. And the most important part is these three, the border gateway nodes. Okay, the border gateway nodes actually used for interconnection between fabric and external networks and service resources. Okay, basically the border gateway is used to allow, for example, maybe we have one user connect to here, okay, and it want to access the external network, okay, external network. So the border gateway will function as a gateway, the border node gateway, to communicate to external network. Okay, so basically all the traffic from inside VXLAN to outside of the VXLAN will go through the border gateway. Okay. Okay, the next one is transport node. Basically, transport node is just a transparent transmission node of fabric. Okay, it doesn't support VXLAN and it can classify into layer 2 or layer 3 transparent transmission scenario. So basically is, okay, we configure VTEP at the border and we configure the VTEP at the edge node. So in between, okay, between these two nodes, it will form a tunnel. Okay, and when there's a packet, okay, from a PC sending to here, okay, the data packets will be encapsulated with VXLAN header. VXLAN header. Okay, once the packet is sent, it will forward it to this transmission node. Okay, and as you know, this transmission node will not configure any VXLAN configuration, and it doesn't maybe it doesn't support VXLAN. So it will not do anything with this packet. It will just forward this packet to here. So at our border, it will decapsulate. Okay, it will remove. Okay, it will remove the header and leave the data packets. Okay, so this is what it means by transmission nodes. Basically, transmission nodes, it doesn't support any VXLAN or we doesn't configure any VXLAN on it. It will just transparently forward the packets. Okay, from border to edge. Okay, so next is the edge node. Okay, edge node, we also call it as fabric edge devices. And edge node is usually connect to the user side devices such as the PC, okay, the IP phone or everything. Okay, and sometimes we will also connect to access devices such as the access nodes for switch and AP. Okay, so okay, for extended access nodes, usually these parts we call it as extended access node, and this part will not include, is not included in VXLAN. So no, there's no any VXLAN configuration configure on these switches. We will only configure the traditional VLAN and maybe some traditional IP address. That's all. Okay. So the main things, the main VXLAN network will only be between the border gateway and the edge. Okay. So these are some of the important terms that you need to know for the VXLAN.
I have a question.
Yeah.
Regarding this transmission node should be the part of fabric. If it is not a part of fabric, if it doesn't know VXLAN, how can it transfer VXLAN packets? So normally when we talk about transmission node, the spine is most of the time the transmission node because it doesn't create any VXLAN tunnel, but it is the data path. For example, if data is sent from TOR1 to TOR2, like access switch 1 to access switch 2, the actual VXLAN tunnel will be created between the access switches, but the data path will be the spine. So we can say the spine works as a transmission node. Then if the traffic is between the border leaf and the this access switch, in same way the spine will work as transmission node, but it will be the data path. So it should know, the spine should know VXLAN network. It should be part of the VXLAN domain.
Or here, the transmission node, actually, we also call it as transparent nodes. So, okay, in our case here is it will only forward the packets through using the OSPF layer 3. Okay. It will only forward the packet through layer 3. So it or not support. Okay. This is either choice, but it will still works. Okay.
Okay, continue.
Okay. So let's continue. Okay. So these are the different deployment mode for the edge. Basically, there are different ways we can deploy the edge. Okay. The first way is we can deploy the edge on our aggregation switch. Okay. And we have our border and at the core switch. Okay. Another solution or another way we can deploy it is we will have our fabric edge at our access switch. Okay. So our aggregation, you can configure as transparent. So we will just transparently send the packets, okay, to the fabric border. Okay, so this is the second solution, and the third solution is we can have a native AC as the edge. Okay, so in our cloud campus we have 3 ways you can deploy the edge. First is on the aggregation, the second one is on the access switch, and the third one is on the native AC. Okay, so next. Okay, so in VXLAN scenario, okay, we have 2 types of scenario. The first one is centralized gateway. Another one is distributed gateway. So what is the difference between these two is in centralized gateway, we will have our layer 3 gateway located at the border. Okay, so for example, we have one device here, which is in VNI 10, and then we have another device connecting to here, which is in VNI maybe 11. And here also we have one VNI 11. Okay, so whenever the VNI 10, the device in VNI 10 want to communicate with the device in VNI 11, it will pass through here, pass through the VXLAN tunnel, go through here, the layer 3 gateway, and then go back. Okay, go back, and then go to VNI 11. Okay, similarly, if you want to communicate with the device here, it will also pass through the layer 3 gateway on the border and go through here. So this is the centralized gateway means. So all the gateway will be deployed at the border. Okay, so for distributed gateway scenario, okay, we will have the layer 3 gateway deployed on border and also the edge. Okay, the edge. So instead of only a border, all the gateway will be distributed across the edge. So again, same thing. We have VNI 10 and VNI 11. Here we also have 11. So now if VNI 10 want to communicate with VNI 11 and they are connected to the same switch, so instead of going through the core border, it will just directly go through our edge and we can directly communicate to the VNI 11. So however, if he needs to communicate with the VNI 11 located at another location, then only it will pass through the border and go to here and go back to this device. Okay, so the main difference of these two is centralized gateway. It will be centralized on the border. Distributed gateway, the layer 3 gateway will be on the border and on the edge. Okay, so these are the two main difference of these two scenarios. Okay.